Hello everyone. In this video, I'll be giving an introduction to rootkits, and then I'll be explaining the working of the rootkit, and I'll say something about the different kinds of rootkits.
So, what is Rootkit? Rootkit is a software used by an attacker to get administrator level privileges. He uses it to have continued privileges access to a computer. And the most important thing is it remains undetected. The rootkit generally contains keyloggers, password sniffers, remote consoles, backdoor, and much more things.
So now we know what a rootkit is. I'll be explaining its working now. The rootkit hides itself and covers up the traces of its activities. It does it by replacing the operating system calls and utilities by its own modified version. For installing rootkit, the attacker requires the administrator access. He does it by using programs like viruses or Trojan horse programs, and after that he'll install rootkit, which will help him to maintain the hidden access and score. This is a scenario which shows how the rootkit remains itself undetected. Uh, in this scenario, the user is trying to get the list of the files in the C drive, and for this, he will use the read file system call in some DLL of the system. The DLL will be generating some NTFS command to get the list of the files in the C drive. The results will be filtered by rootkit's DLL file, which will be returned to the uh, user, and the user will not be knowing the existence of the rootkit folder in the system. There are different kinds of rootkits, and I'll be explaining the few important one of them. The first one is persistent rootkits. A persistent rootkit is the one associated with the malware that activates each time the system boots. Because such malware contains the code that must be executed automatically at each system start or when a user logs in, they must store the code in persistent store, such as the registry or the file system, and configure a method by which the code executes without the user intervention. The second type is memory-based rootkits. Unlike persistent rootkits, memory-based rootkits are malwares that has no persistent code, and therefore does not survive a reboot. So, if we reboot the system, the memory-based rootkits will not affect the system.
Third one is user mode rootkits. This allows attacker to alter security and hide processes, files, system drivers, network ports, and even system services. The diagram shown here is computer security diagram. User mode rootkits mostly resides in ring 3. Any anti-rootkits which has kernel mode privileges can detect user mode rootkits and remove them easily. Fourth one is kernel mode rootkits. It's unlike user mode rootkit, it has kernel mode privileges. It remains undetected from kernel mode anti-rootkits, so it's very difficult to remove these. In most of the cases, rebooting the OS is the reinstalling the operating system is the only option. Fifth type is firmware rootkits. This is even more dangerous than other rootkits. This will be generally found in embedded systems. The recovery is difficult. Most of the cases, hardware replacement is the only option. These two are the rootkits which are commonly used on Windows platform, Hacker Defender and Foo. Hacker Defender is a hybrid of typical rootkit and Trojan. It can make all its activities undetectable. It resembles a rootkit, while it can also open many ports and create backdoors through which a remote user can connect just like a Trojan. Hacker Defender was created long back in 2003 and was considered one of the most dangerous rootkits of those times. Most of the antivirus softwares incorporate rootkit detection, and Hacker Defender can be easily detected by all the major antiviruses. Hacker Defender has evolved a lot. Now it can stay undetected from antivirus. Foo. Foo is a word from the Unix program Su. Su is used to elevate privileges. The foo rootkit can hide processes, elevate process privileges, fake out the Windows event viewer so that forensics is impossible, and even hide device drivers. It does all this by direct kernel object manipulation.
And the well-known rootkits for the Unix platform are Suckit and other. Suckit is a fully working rootkit that is loaded through /dev/kmm. It does not need a kernel with support for loadable kernel modules. It provides a password-protected remote access connect back shell initiated by the spoofed packet and can hide processes, files, and connections. And Adore is a kernel module which is intended to give a cracker the full run of compromised systems without detection. To that end, it installs itself into several key parts of the kernel and lurks until somebody comes along who knows the right key, where the key is a special process ID. If you do not know this key, key signs of the other installation will be difficult. This is a video presentation by Shiva Prasad and Amarnath. Thank you.